Thank you, Prabhu. Hello, everyone. My name is Ramesh, and this is my colleague Mohan. We are from TransUnion. We represent TransUnion Global Capability Center here in Bangalore, and we build products that generate insights and information for good. I represent a business unit that is building products for trusted call solutions in the telecom domain. Mohan represents risk. So great to be here, and today we'll look at some of the key examples of where we are using it from both an operational and business intelligence perspective. Hopefully you'll be able to take away some of the learnings when you architect and optimize your systems. All right. So the elements of AI search are definitely needed as the relevance of search is growing both for operational and business intelligence needs, right? And each of these infra decisions, be it managed or in our own self-run mode, have grave implications in terms of cost, complexity over a period of time, right? And it can be both positive as well as an opportunity for optimizing it. So, as was touched upon in the previous session as well, OpenSearch comes up with a very rich set of search options for you that is scaling as the technologies are evolving and as the relevance needs are evolving. And we wanted to focus on highlighting the differences between these technologies when you're doing it from a managed perspective versus when you are doing it in a self-run mode, right? That way, you can make the right decision and migrate for each of the use cases, either operational or business. Now, when would you need to make these decisions, right? When you are either doing transactional search, where each of your transactions need to touch OpenSearch, or you built operational systems based out of OpenSearch, where you're streaming billions of metrics, logs, traces onto OpenSearch. That's another scenario. The third scenario is maybe you're aggregating it and generating business intelligence out of those. So each of these search options and technologies are relevant, and you can make a choice as your systems scale, and you are pivoting your use cases in each of these cases, right? With that, we'll move to the first example. Now, I wanted to give an overview of the various search types. Well, keyword search was the bread and butter long time back. It's no longer even an appetizer now, right? Vector search came in and it brought in the relevance, the first sense of intent, right? It doesn't matter what you type in, but what is your intent with which you are typing in, and we want to cater to that, right? That context is brought in by leveraging embeddings, ANN, KNN plugins, and so forth, as you're aware. So if your use case is a transactional search, typically the recommendation example comes into play, where you have something, you want something similar. So that's when the easiest option, or the first option you start exploring, is vector, right? And all these are very well explained with examples in the OpenSearch documentation as well, right? One step ahead is semantic, where you take it ahead and you use word and sentence embeddings as well. So what that means is a sense of, okay, today my tax is this, maybe after a month a tax will increase X% or whatever it is, based on usage, cost, earnings. Rather, you are qualifying it by saying, I want to reduce tax legally, right? So which means you need to look at multiple sources, right? And that's why you need to dig into not just whatever you have in your system, but rather dig into something that has been found out via common crawl or open LLMs, right? Next comes neural search. right? Here we dig into deeper understandings, right? When do we need deeper understandings, if you will, right? When we have common human questions, like how do I fix an error 500, 502, especially when the context is your architecture, your load balancer, right? Be it hardware load balancer, be it your own elements in the network or your application errors. There is a variety of things, right? If you have all the time in the world, you can go through all of that. But when you want to build a system that will run without you, given all the documentation, run books, and all of that, that's when we dig in here, all right? Moving it still further, taking that conversation one step ahead, when you want to add context to those queries based on what was queried yesterday, right? Or last week, because maybe most of the times it's a trend, right? One customer sees an issue, it's just a matter of time before the other person also sees if it's not intervened, right? That's when you want to persist some level of, in your memory, previous queries, rewrites, and so forth. So typically, these scenarios, right? Whenever there is an offering, a peak season, you typically get those kind of search queries. Multimodal is the most complex. As of now, I'm sure there will evolve many more scenarios, right? Visual representation is the easiest for a human to understand, and that's why multimodal is very, very important, right? Instead of talking, instead of explaining, multiple prompts, you give it a picture and say, this is what I'm getting, give me a solution. That's when you jump into multimodal. Whether it's operational perspective or business perspective, the same things will happen, right? Last peak season, I had this peak transactions per second. What can I forecast now? It's a loaded question. Maybe it's an X% easy extrapolation, or so many things have happened that is there as data in your OpenSearch system. That context can come in and help you as well there. But you're not sitting there and writing all those prompts and interacting with it, but you're giving a picture and expecting a picture back in a way, right? I'm simplifying it further, but to get an idea, that's where we are. Oh. So hopefully that gives you a good view. Digging further into specific examples, let's take the operational example of semantic search. All right. Essentially, you are bringing in embeddings. Your document with vector embeddings is stored in OpenSearch itself, right? So search becomes easier with this context. Now, where will you typically use this thing? If it's an operational scenario, if it's a search scenario, you might want to ask this question, example, right? What was the maximum traffic in the last 3 weeks? A very simple question. But all that context has been already loaded through the embedding, so it can easily generate that. This is a very simple semantic search scenario, right? Otherwise, you go write in that entire query, and it changes over a period of time, right? Maybe you can build a report, dashboard, all of those things are there. But here, the scenario is, you want to do this in an automated fashion. You want to do it in the most efficient manner. Maybe you want to plug it into an agent at some point, right? So that's the potential this offers, okay? This is just to drive home how you can use it in an operational intelligence. For a business intelligence, it would go back and say, what was the highest number of transactions or the highest amount of revenue that was made in the last 3 weeks, right? Because it's derived out of an aggregation of this. Okay. Moving to the next scenario. Conversational is a little bit more involved, right? Where we want to clearly say there is some context, SLA, violation, when was this last observed, right? All of this is coming in, so you definitely need a RAG LLM in that case, right? And there is a variety of them already supported by OpenSearch. You can as well use external models for that. And the value they bring in is this: what is SLA? What is violation? but the get client data API is your own metric, right? So combining those things is what this helps, all right? And typically you would see these scenarios, CPU goes ups and down, depending on peak season and whatnot, right? So it's so easy when you adopt this model and ask that question, right? When was this last observed? What were the metrics at that time, right? Moving forward. From a hybrid perspective, if you see, it's a mixture of scenarios. How many timeout errors occurred in the payment workflow, for example, right? Over the past 3 days. It might appear like a simple numerical aggregation, but it's a little bit more loaded. We are talking about timeout error as a keyword match in your logs. We are talking about semantic match, payment workflow areas, APIs, right? There could be one, there could be multiple, there could be an aggregation of APIs. So you need to feed in all of that documentation or your Swagger information into that. So this will be able to combine both of those and give you those results, right? Moving forward. And the most complex scenario of multimodal, right? In incidents, we have commonly seen this. Web server is down. That's what the customer is observing, sending an email, hey, I need immediate support, right? This is what he's observing. Maybe you are not observing. So you go through the entire troubleshooting path, step by step, or you have your runbooks built out, you feed it whatever image the customer has sent, and have OpenSearch do all the work for you, right? The thing is, the runbook once created doesn't go waste, right? It evolves over a period of time. Same way, most of the times we have seen even this 500 error, right? Or when, from an external perspective, 502, say you're using a CDN, Cloudflare, whatever it is, right? There is some connectivity issue. These are very typical examples from an operational perspective. From a business perspective, it will be much different. Hey, there is a dip, right? Obviously, when customer is not seeing traffic, potential for revenue going down is there because no transaction is happening, right? So that's a more derived metric that comes into play there. All right. So with this overview of the search methodologies, I'll hand over to Mohan so that he can give us a view of how does it differ between managed versus self-run, and what was the approach we took when we took our products, transactional, operational, and business intelligence scenarios, when we build it out using OpenSearch. Yeah.
Thank you, Ramesh. Okay, so now we understood what are the different search types OpenSearch offers, right? And now we have to either look for hosting it on-prem, or if you're able to afford and managed service, you can go for it, right? So first we have to look what are our infrastructure needs to avail all these search types, right? So we have semantic, hybrid, neural search, multimodal, conversational, right? So if you look at it, so when you start from semantic, you may not need much sophisticated hardware. You can go with the moderate one, and it may not require a GPU. So you can go with the regular CPU usage, right? And then again, in terms of managed service, you can go for like regular R6G AWS instance types for hosting it. And you have for semantic, basically it works with the KNN model, right? So you have to go for a plugin for it. So that would be your special need, right? And when it is hybrid, that combines both your keyword search results plus you need to have vector search, both of them to be combined. So again, that is more efficient. Like if your current application is fully keyword driven search, and if you're going with semantic or vector search, like better to have a hybrid in the beginning. So that way, some of the results would come from keyword driven that will match the existing criteria, and some of them can be taken from a vector search and then can be embedded. So when you do that, you have to have some plugins for blending the scores that comes from the keyword driven and the vector. So when you go for neural search, you need of course little more better hardware, and then you need to host ML models. So when you set up your cluster, you may have to accommodate all that. And so you have again plugins for neural search that you can do, and then you need better faster IO operations in the disk. So that is something you have to accommodate in the infra. And when you go for multimodal, you have to process audio, image, everything. So for that, it's better to have very high RAM, and GPUs more sort of essential. And you should have a separate storage needs, because when you process a lot of images, audio, you may have to accommodate more storage. And AWS offers some of the instance types specifically for this with better storage efficiency with M6G, right? And for conversational, you have again highly recommending GPU, because you need to host large models over there for storing the context and chat history. And again, there is an OR1 model instance type, which again AWS offers, so that specifically made for like OpenSearch optimized instance. So that gives more cost-effective solution for large volumes of data to store for chat history and the context, right? Again, when you go for either managed service or self-hosted, you have to accommodate the various aspects for your application. How is your cost getting involved, and how fast you can scale? Like if your custom number of transactions are increasing, how fast you can scale this search, right? And then you have to accommodate your deployment, flexibility in terms of maintenance, and you have to accommodate if your application is more SLA, or if you are hosting APIs, you have more your customers are more sensitive to the latency, then you have to accommodate that as well. By introducing these new search types, you should not introduce additional latency to your customers, right? So of course, when you go with managed service, you may have to initially the cost little bit higher end, and then but you will be able to scale faster. And maintenance wise, you have less effort. The managed service takes care of patching and all the maintenance aspects, and you may have little flexibility, but you may not be able to have more customized plugins, etc. In terms of managed service. And of course, for deployment, it's easy to deploy when it is managed service. But it's on-prem, you need to have your experts, DevOps engineers to take care of the deployment and building pipeline, etc. So in terms of cost perspective, if we think, right, so we have given an example. Say if you're planning to store 100 TB of data with 3 data nodes, when you try to set it up. So if you have to set up initially as a self-hosted one in your on-premises, then you need to have initial setup where you have to procure your hardwares, all of that, right? And that would cost about $1 million. And then again, you need to have monthly maintenance. Again, that would be very high. You have to have monitoring in place, and you need to have DevOps engineers to, if there are issues, to support, etc. Right? So you would be ending up paying a lot of monthly maintenance. And then scaling, again, you may have to manually scale it up. And then you have to afford to have staffing cost, right? Like hiring experts in the DevOps side and infrastructure side. And you have to, again, you're already procuring the hardware, so maybe a fixed cost for the storage and then compute, right? And if you go with the managed service, it's in the initial setup, it's very low, because the managed service takes care of it, and you may not have like too much maintenance monthly. And you have scalability wise, when you go with managed service, there are a lot of auto scaling features available, and then you have like stringent, you can set up stringent SLAs based on your customer needs, etc. Right? And patches and security updates are taken care seamlessly. And yeah, of course, for the compute and storage, you may have to pay as you go. Like there are various instance types based on your search AWS offers. So you may have to pay based on how much utilization that you're having for storage and compute. And in our use case, like we have gone with, for some of our use cases with AWS, and then there are some of the estimated numbers are, or like the utilized numbers are given here. Okay, so that's in terms of the hardware and infrastructure, and let's look at some of the best practices for each of this search type, right? So when you go with semantic search, it's basically vector based, right? So you need to have KNN plugin, or if you still need to have more faster retrieval, you can go with approximate KNN that does the approximation if you have too much of data, and then it retrieves your results fast, right? And you need to normalize your vectors before for indexing and querying, right? Like this helps again to have the same numerical values. And you need to have two different indexes for the keyword fields and the vector fields, so that we retrieval and there is no mix of data. And there is a recall versus latency trade-off that you have to be watchful on the semantic search. There are a couple of parameters that you can watch for, right? So when EF search increases, your recall improves, but latency also increases, right? So it's a runtime parameter where it impacts your query performance in the runtime. But in the EF construction, again, if it increases, you have to be watchful about your latency, but that is during mostly the training time or when you are storing the data, right? And if you have more embeddings or more storage of data, then you can opt for feature store, where externally you can store your embedded values. So that is also another option. Moving on with hybrid search. Again, here it combines both semantic and the lexical search results, right? So here we have like we can use multi-search or re-ranking to blend the lexical and vector scores, because you will get two scores. You have to return your result based on both the scores that is retrieved, right? Like, so these plugins offers like so multi-search is parallelly runs like your lexical and semantic search, and then it gives the results. And there is a re-ranking where it's a two-step process. You can use a re-ranker. First you get your the lexical search results from BM25, and then you can get as a second step, you can get the vector search results, and then you can re-rank based on additional models. So based on, again, use case, if your application is SLA driven more, then you can go for multi-search, or if you can afford some latency in terms of search results, you can go for re-ranking. And then again, there are additional plugins like script score for hybrid scoring logic, where you can have customized script for scoring. Once you get your the lexical result and semantic results back, for scoring you can still on top of it can have custom script that will help you to score. Maybe you can take like 60% of the lexical value and 40% of your vector result value, and then you can have that. You can optimize those numbers based on how it works out for your application, right? And again, rather than test data, if you're able to afford to with real user queries, if you're able to benchmark the performance for the hybrid, that would be much better. And then there are again plugins like for query expansion and synonym filters. Again, query expansion is more sort of when the query is given, right? So you can add automatically the additional relevant context to the query, so that improves your answer. Like, say for example, if there is a search term called car, then you can add maybe additional relevant terms like vehicle, automobile, something of that sort. So that way all the relevance is exactly understood, and then you may get accurate results. And you can have like hard-coded synonyms as well, based on your application domain. You can have standard set of synonyms for each of the words based on your user usage. That will again help to improvise your accuracy in terms of your hybrid search results. Moving on to multimodal. Again, so here when you go for multimodal, you have like more image, audio, text, everything, right? So you need to have separate indexes for each of the modality. Say, assume you have text and some of the information coming from the image and audio. So you can have separate indexes for each of it. And for each of them, you will have numerical values. Say for this image represents this vector, and again this audio represents this vector. So say for example, for text you can use BERT or OpenAI sort of models, and for image ResNet, Clip, there are a lot of models available, those you can use. And again for audio you have wave to vector, all sort of those things, all gives you the vector numerical values for your multiple inputs, right? So, and for each of this input, if it corresponds to a text or search, right, so you need to have separate metadata which will help you to retrieve the data very quickly, right? Otherwise you may have enormous amount of data that may hamper your system performance. So trying to have metadata for each of these filters helps to narrow down the search results, or the number of entries that goes to the vector search. Further it gets narrowed down. That will help you to have a faster retrieval of data. And you have OpenSearch ingest data pipelines that Ramesh covered initially, where you have you can have set up data pipelines completely in the ingest pipeline. You can clean and normalize your data, and you can add metadata to your text or images or audio, right? And then you can apply either normal ML model or NLP models for your text, and then you can store it with the help of this pipeline. And then of course for multimodal you need to have high IO throughput, so that way your queries can be responded faster. So moving on with some best practices for neural search. So again, neural search, mostly it uses a lot of models. So there are a lot of options available. So you have Colbert, again that is contextualized late BERT model, where you can use for faster scoring, right? And then you have Splade, Tile, all these again mostly on the text side. It will help you to represent the sparse matrix values, right? And you have so you can have weighted tokens for each of the custom analyzers, like, so you may have custom analyzers to understand the query given. So for that you can there are multi-token fields where you can have weighted tokens for each of it. And again, if your application is more SLA driven, and if or if there is a low confidence in the neural response, again you can have some fallback mechanism, either go with vector search or normal lexical search. And there are again few things you have to monitor or careful about the neural search, mostly on the index size and the token explosion, since the data is sparse matrix. So you have to be watchful about index size, where it can significantly grow the index. It may cause some storage issues. And then in terms of token explosion, if you keep per document too many tokens, then that may result again in slowing down your query results and then storage issues. So these metrics, there are like monitoring tools available to monitor these metrics, so that way you can fine tune or have good control of these fields. And again, query rewriting, again adding some relevant terms or synonyms to your query, having some logic before going further vector search would help to getting accurate results. Okay. So moving on with conversational search. So here, yeah, you have to have the context. You have to store the session context and chat history. Again, prefer to have a dedicated index for these. And then again, we have talked about query rewriting, right? Like in the previous slide. So for conversational search, you need to have contextual query rewriting based on the previous n number of questions. You can rewrite your query that is going to be sent to vector, right? So that way, the more specific context is retrieved. And there is something called semantic re-ranking, where initially, with the help of vector search or BM25, you can get the semantic of the query given, and then post which you can use any deep learning model to re-rank your query parameters, and then further you can go for the results. So that will again help to improvise your relevance in the results. And yeah, you can integrate the RAG pipelines, LLM models, so that will again help you to have more accurate results in the conversational search. And here you may have to monitor the query drift and session abandonment. So query drift is something, these are again metrics that will help you to evaluate how best your conversational search is helping you for the user queries. So query drift is more sort of how many of the user queries you are able to relevantly respond back. So if it is increases, yeah, more drift is there, then you may have to be watchful or fine tune some of the parameters. And then again, session abandonment is more sort of how many of the user sessions are closed without getting the complete context or answer from your solution, right? So these two indicators will help you to understand how far you're able to keep the user, right, stay in the conversation, and you're able to answer their relevance. Okay. So those were some best practices that we have come across. And then when you go for, again, I think in a nutshell to cover up the takeaways, right? So when you go for managed or self-hosted OpenSearch, so you have, when you go for managed OpenSearch, you have, I mean, setup is quick, as you know, like, yeah, you just have to subscribe for it, and then initial setup comes with few buttons click, right? And you have the maintenance is purely handled by the provider, and then scaling is pretty much auto-scalable most of the cases, and then security is built in most of the times, and then any patches, all the upgrades, everything is taken care. And when your business is in a starting point, you may pay less, and then when your business expands, you can you'll be able to afford to pay more, right? So again, yeah, you may have a customizations in terms limited options. Of course, AWS provides managed service very well, and you have yeah, if you want to host on your own, then yeah, you may have to manually provision all the setup with the help of some expertise, right? And maintenance and scaling is either scripted or your responsibility. And the security, you have to take care of the security patches and all the security parameters, IAM, everything has to be configured by your side. And you may have your infrastructure cost and operations cost to take care on your side, right? And for customizations, of course, when you manage by yourself, you may have full control, and you may have to host it with Kubernetes, or you can go for bare metal or VMs, right? Yeah. So here are some other takeaways. So yeah, as you have seen, like OpenSearch offers various type of searches with the help of AI, right? So it's the good time to harness this AI capabilities in your application, right, for operational and business intelligence. And again, for your use case, you evaluate which works best, right, which search type is needed. You don't have to go with always conversational or like higher end, right? Like you can, based on your product use case, you can evaluate and adapt most suitable one. And then yeah, to maybe start with, I mean, if you want to go fast to the market, you can start with the managed service that will help you to go fast in the market, leading ahead of your competitors, right? And it will have seamless integration when you go with managed service. And then later, for flexibility, once you gain expertise, then if there is a need, then you can think about going with the on-prem services.
And there is a midway as well, the serverless, right? So if the scenario is business intelligence oriented, you may want something generated every day, every week that business folks look at. That's a little bit more focused area or use case for adopting serverless. Right? And from an operational perspective, if you think about it, right, enriching that data is in our hands. In the DevOps engineer's hands, it's in the operational folks' hands. You can actually arm your data with more annotations that will help you extract intelligence out of that. Right? Typically, our logs are more, dev speak, right? We know key value pairs and stuff. But on top of it, you add annotations. Okay, this upgrade happened this time. We added this feature and all of that. That becomes text, right? So apart from querying for response time and graphing it, alerting, if we have this text context as well go into your OpenSearch, you'll be able to actually correlate and do things like, oh, this X peak season, and last time we did this upgrade, it behaved like this. Last time there was this incident X, it behaved like this. So when a similar observation is there, it'll take you back and say, oh, this scenario, either with the CPU, system metric, application metric, this is a reference. Last we saw here, right? So there are methodologies that we learn over a period of time that we can adopt to make our data rich, that gets ingested, and it will only help when we do any of these AI search methodologies, right? And from a business intelligence viewpoint, one more key call out is, if you are handling multiple regions, if you have global customers, say US, Canada, South America, Europe, multiple regions, right? Intelligence from one region can only help enhance in another region, right? Typically, it requires manual intervention for us to shift, say, or traffic from east to west for whatever reason, or divert some traffic. Now, all of those aspects can be automated as well, eventually using agents and other methodologies, if you adopt all of these annotations and leverage the AI context as well. Okay. Great. So with that, we would like to summarize and open it up for questions.
Any questions, folks?
So my question is more around the analysis that you did about self-managed and taking a managed service, right? Was there any study that you guys did on 100 TB of data for if you take the compute from Azure or AWS and then try to self-host, what is the cost difference?
So we have different application divisions. So Ramesh is part of a different division where like we have huge use of AWS, and then I'm from a different division where we have predominantly using OpenSearch in the on-premises. So but we don't have equal amount of data. So like we have say 50 TB of data. Ramesh has like 100 TB of data that is hosted in AWS. So we did comparison based on these two and extrapolated from 50 TB to 100 TB, and then based on that we have come up with those numbers. Again, depends on your, it varies, it's an approximation, it varies based on your use case and then what search you want to run, all those factors.
Right.
So your compute is also self-managed or compute is basically cloud?
Compute is self-managed. You can opt, that example that we showed, right? So when you opt for managed, you need to pay for the instance as well as the storage separately, right? In addition, if you adopt external models, that's a different cost, right? Built-in models come with it. And the third part is also that apart from the instance and storage, you want to choose, and that's why those instance types, what is warm, what is cold, you want 3 months or 6 months. Naturally, if you if your retention period in OpenSearch, or for that matter, any store, if the retention period is more, it's a trade-off, right? Your intelligence will be good, but cost will be more, right? So you need to roll off things to S3 or something like that, and you need to manage that. That balance you'll learn based on your data, the regions, and all of that. Some regions handle lower traffic, so we went with a self-run approach. But when we started off, we chose a managed approach because we wanted to learn. Managed makes it so easy to do patching. Anyone has done patching on a routine basis for compliance will know how big a deal it is, right? It's heavily underrated, but definitely something you don't want to get into and waste your days, right? But something that needs to be definitely taken care of and also measured, right? And that's where, even when you have audits, which is a common thing, right? What happened? These are common questions that come across during audits, right? How are you sure when you did it last? Show me the scan. All of those things, actually, we started doing it in OpenSearch, right? So,
yeah, like regarding the external model connections and all, how was it on the self-hosted? Like this one, OpenSearch has a better documentation if we have it as a managed service connecting to a SageMaker model or something like that.
yes, a variety of them are there. Same thing you can do self-run. The only thing is you need to do it yourself and all of that. In fact, to start off with, you can connect to Hugging Face models and all of that. They've also given something to play around.
Model is
Yeah,
fine. Like
right.
basic sentence vector, I'm talking about like anything which is a large model self-hosted on SageMaker or like that. So how good is the documentation basically if we are running to migrate to a self-hosted? That's all.
Yeah.
I think, no, actually a good point, right? Where we felt we needed more information, apart from the documentation, actually, that's one benefit with managed. You can actually have them answer those questions, right? And that's always the trade-off. I agree. The more complex it became, there were undocumented or hidden things that you need to go and discover. But the basic thing works. The moment we move to production and see it for some time, that's when we started observations, and we needed help from managed. And then after we were comfortable, that's when we started experimenting things like, oh, I'll go with ARM processors. I'll go with specific optimizations. I'll choose Anthropic, or I'll try this for 1 month and see how it goes, right? So those differences, actually, we were able to try it out. Basic documentation is there, and when things were not very clear, managed was much better actually for us. Yeah.
The last question is basically how do you compare managed cluster and serverless, and when do you choose serverless collections versus normal indices?
Sure. Yeah. So the key scenario for serverless for us was for business intelligence, because operational, it's always on, right? There is no compromise there at all. Business intelligence, typically they look at weekly reports, trends, right? Last peak season, last incident, when we added a new customer, how is US trending? These are all business intelligence scenarios. In fact, apart from OpenSearch, there are various other common libraries, Supersat, and those things also can help in a way, right? But serverless, key scenario for us was business intelligence and reports, because it's a once a day, once a week, once a month. We need to generate that, right? In a way, yeah.
Okay, one last question before the lunch.
So you mentioned that auto scaling is available in managed service, but isn't auto scaling very painful in even managed service? Because when you auto scale, you basically have to take care of the number of you have to basically take care of the sharding as well, and depending on the you could be managing tens or different hundreds of indexes. So how is that auto scaling very easy in managed service?
Got it. No, very valid point. See, you need to set the right metrics there, is the scaling based on the transactions per second, or going so specific about only CPU or memory, right? So when we started off, we played around with those, and only the combinatorial things worked out for us, right? So all those options actually are available to set in the managed option also. We played around it a little bit, and it differed in each region because the traffic pattern differs in each region, right? That's for the operational scenario. For a business scenario, there was almost no need for us to go with auto scaling because most of those were reports, right, for business intelligence. But operational, there was comparatively very good support compared to self-run. Right? Yeah. Serverless also, you can configure it, but we never felt a need. Right?
And again, it's a relative thing, right? Like, so self-managed, yeah, you may have to procure additional hardware and so many other stuff. Again, depends on your organization how quickly you can procure additional budget and all of those, right? Like, but at least those sort of a headache is not, you don't have it in the managed service.
Agree. I mean, from a capacity planning perspective, you can set those thresholds, X% max and so forth, right? Yeah. And it's actually a combination of that and retention periods also. So you can play around those levers.
Okay, I think we have a few more questions. Maybe we can continue offline. Ramesh and Mohan is going to be there all through the day. You can reach out to them and get clarified. Thanks, team. Have a good lunch.